In the last video, we looked at a few examples of mathematical models used to generate predictions and figure out what's going to happen using typically algebra or graphs. Most of this chapter, we're going to focus on linear models that display what we call linearity. Sometimes this is just reality, how things are done. Sometimes this is an assumption, and often that assumption is based on things we see in the data. But what does it mean to be a linear function? Well, the meaning is that there is a constant absolute rate of change. So if I change one variable, the independent variable, my x if you will, by 1, then my y, my dependent variable, will change by some constant fixed amount, no matter where x and y are. This rate of change is called the slope. Let's look at a couple of examples, one which is an example and the other is a non-example. In this Excel file, I have two different depreciation methods in two different sheets. We're looking at method 1, and if I click on the tab at the bottom, I see method 2. So what is depreciation? Depreciation is how we expense a large cost item over time. In particular, accountants want to match the expense with the revenue it generates. So in this case, you can see in both of these examples, let's say it's some piece of machinery for our business costs $75,000. Well, if you put that $75,000 as an expense in your books when you buy it all at once, first of all, it'll generate an odd-looking spike in your cost. And second of all, the revenue that you're going to generate by using that machine will be generated over time, and accountants want to match things up. So you expense it as you use it. And you may expense it by a constant amount every year. That's called straight line depreciation. That would be linear. Or you may expense it some other way. The resulting value, if you start from what you paid for it, in this case $75,000, and you subtract off how much you've expensed, what's left is called the book value. So what we see here is the year or the age of the machine in column A, and the book value after depreciation in column B of whatever this piece of machinery is. The book value should not be confused with the market value, which is what you can sell it for. So let's investigate which, if any, of these depreciation methods are linear. Well, we're going to look at the absolute change from one year to the next. What is the absolute change? Well, we simply subtract. So there's no change in year 0 because we're just starting, so I have to start here in year 1, and I'm just going to take a look. I'm going to take the book value in year 1, which is in B3, and subtract the book value in year 0, which is in B2. And this is accounting language. The parentheses mean negative, and you can see we reduced the book value by $10,500. That's how much we expensed that year for this machinery. And now I'm going to drag and drop, and let's see the patterns, if any. We can see by looking at how much we expensed every year, which is the change in the book value, that the absolute change for depreciation method 1 is non-constant. That means we're not expensing the same amount every year, the book value doesn't change by the same amount every year, and this is not a linear model of the book value. Turns out this is actually exponential, and we might come back and take a look at the very end of this chapter as to why, but it would be called declining balance depreciation in accounting terms. Let's do the same thing for depreciation method 2. As before, we're looking at the absolute change. That's how much we expense each year, and which is the change in the book value from one year to the next. So as before, I simply tell Excel to subtract consecutive book values. So in the first year, we expensed $2,800. That's what the parentheses mean, we expensed. Let's drag and drop and see if there's a pattern. And indeed, you can see that there is a pattern. And this pattern is that the absolute change is constant. That means depreciation method 2 models book value as a linear function of the age of the machine. So in depreciation method 2, we saw what's called straight line depreciation. The slope The constant rate of change for the book value was negative 2,800. What that means is every year, the book value decreases by 2,800. And you can see on this slide the graph I generated from the Excel file, which shows that the graph of the book value over the age of the machine is a straight line, hence the name straight line depreciation. And linear functions, their graphs are always straight lines, hence the word linear. Let's look at one more example. This example comes from the wiki for World of Warcraft. The wiki page I found has all kinds of ways experience points can be accumulated by players. So here I'm zeroing in on one particular way a player can gain experience points in one particular portion of the map of that world. That's the Eastern Kingdoms. So I guess what you do in the Eastern Kingdoms and in World of Warcraft is you kill something called a mob. And we could ask, so anyhow, your character has a level, right? They have level 0, level 1, and so on, up to a maximum level of 60, although I guess they're changing that now. And when you face an enemy, a mob, they have a level. So we can ask, how much experience points do I gain when I kill a mob whose level is equal to my character level? Well, how does this work? So according to what I read on the wiki, it starts at 45 experience points if you're level 0. And then for each level that you have, assuming the enemy you killed has the same level as you increase the experience points you get by 5. This is linear. That 5 is an absolute rate of change. As you change your levels, as you increase by a level, every level you increase by, you get 5 more experience points for killing a mob of the same level as you. Let's take a look at what this looks like on an Excel file. So here's our Excel file. I've just begun it. So I've got character levels running from 0 to 60. And if I'm level 0, if I kill an equally leveled mob in the Eastern Kingdom, I get 45 experience points. If I increase to level 1, and then I kill a level 1 mob in the Eastern Kingdom, I get 5 more. So I'm going to take the number in cell B2, and I'll just add 5 to that. Similarly, if I'm level 2, then I kill a level 2 mob in the Eastern Kingdom, I add 5 to the 50, and I get 55, right, equals B3 plus 5. And we can keep going, and in fact, I can actually copy this all the way down to level 60. And this tells me that if I'm a level 60 character and I kill a level 60 mob in the Eastern Kingdom, I get 345 experience points. But what we can see here is that we actually typed this in. The formula we typed in and copied said, take the previous number and add 5 to it. And that's a constant rate of change of 5 experience points for every character level that you have. Right? 60 to 65, 65 to 70, and so on. The way we generated these data is called recursive. We used the previous number and just added 5 to it. We didn't plug in the character level at all. In the next video, we're going to talk about how to create something called a closed form formula, where all we have to do is plug in, say, the number 26, and we'll get an answer rather than having to add 5 26 times.